Okay, so continuing our look at a little review of some basics of cartography for our GPS course. Another concept we have to be clear about are geodetic datums. And what geodetic datums are doing is they have two purposes. One is they define a model of the Earth's surface, and then two, they create what I like to call the origin of a coordinate measurement system. So if you think of a Cartesian plot, an XY grid, the origin is the 0, 0 point, right? And if you know that 0, 0 point, then you can identify other points on that grid or on that graph. So a datum helps us sort of pin our grid system to the Earth. So if you think about those lines of longitude that are the graticule, imagine it's sort of like a little cage around the Earth. And we could move the lines of latitude and longitude around the Earth. The datum locks those lines to the Earth. And that's why if we change our datum, we change the description of a point. So if we are in the same place, so we're right here at this point, but we move this 90-degree longitude line a little to the west, now this point is 85 degrees west. If we move it here, then maybe it's 90 degrees west. So what we're doing, we change the datum, is we're actually kind of adjusting where those lines of latitude and longitude are on the Earth. So understanding what datum you're referencing your data to is really important, because if your datum changes, then your coordinate description for a physical position on the Earth will change. So conversely, we could think of it as we could take our coordinate pair reference to one datum. Let's say we have 30 degrees north and 100 degrees west. If we plot it on a map reference to one datum, it'll plot in one place. If we plot it on a map reference to another datum, but we don't adjust the coordinates for that datum, then the point's going to plot in a different place. Okay, so hopefully this will become more clear as we go on. So these geodetic datums are developed to describe our geographic positions. And like I said, an object might remain in the same place, but if you change the datum, then the way you describe its position will change. So the actual physical location of the point doesn't change, but the description of its position will change. So if we reference geodetic coordinates to the wrong datum, you can actually end up with errors of hundreds of meters. So your point can actually plot in the wrong place if you reference it to the wrong geodetic datum. There are three main datums that we use in the US. The first two that we'll talk about are the North American datum of 1927 and the North American datum of 1983, and NAD 27 or NAD 83. NAD 27, if you look at an old USGS topo map, it'll be referenced to the NAD 27 datum. And this is an older system, and it's not being used as much now as it used to. But there's still a lot of data out there that's referenced to the NAD 27 datum. The newer one is the NAD 83 datum. It's a little bit more robust than the NAD 27, and it is essentially equivalent to the WGS 84 datum, which I'll get to in just a sec. Let me go back here. So the difference, and this is important, this describes this important point that the different datums will result in errors in position. The datum shift between the NAD 27 and NAD 83 datum in meters for longitude, so that's distance east-west. If we go to here in Grand Junction, we're talking an east-west distance that's 58 meters in location. So if you took a point with your GPS that's in NAD 83 and you plot it on an old USGS topo map, which is in NAD 27, your point will plot 58 meters wrong in the east-west direction. So it is really important to pay attention to this, because your points, you want to make sure that we're creating high-quality maps that are accurate, or as accurate as we can be given the tools we have. Okay, so the third datum that we use in the US, and actually this is a global datum, is the WGS datum of 1984, which has been more recently revised. But for practical purposes, The NAT83 datum and the WGS84 datum are essentially equivalent for our purposes in the United States and North America. The WGS84 datum is the basis for GPS data. So the data that are stored, the raw data in your GPS unit, are stored referenced to the WGS84 datum. All GPS data, no matter what GPS unit you're using, the raw data that they store is referenced to the WGS84 datum, and it's stored in latitude, longitude, decimal degrees. We can convert it to other datums and coordinate systems. You can display it on your GPS receiver in other coordinate systems and reference to other datums. But always at its core, that raw data is lat long, decimal degrees, WGS84. So when you use a GPS receiver and it gives you a latitude and longitude, you must know the datum that is the basis for the numbers. Pay attention too that if you're traveling and working in another country, each country has its own datum, or maybe multiple ones. So for our purposes in this class this semester, we'll be using WGS84 mostly, but you may come across data that's referenced to NAT27. But when you travel, or if you're working in another country, you want to make sure of what datum your data are referenced to. And like I said, refreshing, GPS data are stored in latitude, longitude, decimal degrees, referenced to the WGS84 datum. If you change the display, so you're out with your GPS unit, and you change what the coordinates are showing on the screen, you're just actually telling the receiver, take that raw data, convert it to UTM or whatever coordinates you want, show it to me in UTM, but your GPS receiver is still keeping those data in lat long. When you transfer your data off your GPS unit, it's still in lat long, decimal degrees, WGS84. It's not until you export to ArcGIS that you'll change that. So that's an important thing to keep in mind through the semester as we work with these data. So we've been talking about horizontal datums. We also have to worry about the vertical datum. And the GPS default is the height above the reference ellipsoid, which is, the acronym is HAE. Many maps will report elevations above mean sea level, which is usually above a geoid model, and you just have to be consistent and make sure that you convert to match your elevation so that you're using the correct vertical datum and you can make adjustments if necessary.